Good morning, everybody. This is a screencast about dimensional analysis. Maybe you've done a process called factor label method in the past to solve some problems. Well, then you've done dimensional analysis. One of the things you have to remember about dimensional analysis is that the top and the bottom of the factor have to be equal to one another, like a foot is equal to 12 inches. If you stick to a rule like that and set it up so that your labels divide out and you get the label that you want in your final answer, you're going to be fine. What we're going to do in this lesson is use factor label to change 1 or 2 units in a label to the new units that are desired. And we're also going to use it to learn how to change squared or cubed units. Just a real quick example. Okay, let's see, figure out how many seconds old you will be on your next birthday. Okay, I'd say a lot of you are probably going to be maybe 16 or have recently turned 16. So let's start with that. Okay, and let me get a color that'll show up nicely. So let's say that you are on your 16th birthday wondering exactly how many seconds old you're going to be. What you do is you set up factors so that the label divides out and you convert it into a new label, but an equivalent quantity. Like, for example, we know that a year is 365, and we're going to go in a quarter or 0.25 days because of leap year. Okay. We then know that the years will divide out if we take 16 times 365 and a quarter divided by 1, and then our new answer would have a new number and then a label of days. And however many days that is, that's equal to 16 years. It's just being expressed in a different unit. Now, many times what we want to do as far as our conversion is going to require multiple steps, because in this problem, we want to know how many seconds old we are. So we're going to have to continue on and do multiple steps. I really feel it's best, instead of stopping and getting an answer in days where you round off an answer, to just continue on and keep putting your factors one next to another. Okay. For example, we can convert from days to hours because we know there are 24 hours in one day. Top and bottom of the factor are equal. And I set it up. I put days on the bottom so that it divides out with the label that's on the top of the previous factor. Continuing on, we know that an hour is 60 minutes, and we know that a minute is 60 seconds. Now, in this particular example, everything that is, on the bottom happens to be a 1. That will not always be the case, okay? So we can see here, too, that our hours will divide out, our minutes will divide out. And to get our answer, we multiply by everything that's on the top and we divide by everything that's on the bottom. Now, in this case, those are all 1s. If we had a number on the bottom, we would have to divide by it. The order does not matter because multiplication and division can be done in any order. So I'm just going to take 16 times 365.25, which is a quarter, times 24 times 60 times 60. And on your 16th birthday, okay, you are, 504. Okay, let me see. 9216, and 1, 2, 3, 4, 5, 6. I need 2 more zeros because my calculator had it as this, right? So I had, and this is a 0, not a 6. So I had to make sure that when I converted it to standard form, that I had the right number of places. The only unit that remains is seconds. And so on your 16th birthday, you are 504,921,600 seconds old. So a little over halfway to a billion. So this is an example with some quantities that you're really familiar with. So what I wanted to do today was just take this method, which you see here, in quantities that you're really familiar with, and put it together with some numbers that you will be using for conversions this year in science. So you might want to pause here and write these down. These are some conversion factors that you're going to want. I'll be using some of these in some of the problems that we're going to do. And I know that you need these on some of the homeworks and some of the WebAssign problems that you will eventually do, because there's another WebAssign, but it'll be coming up in just a few lessons. So let's say you have something like this. We're going to do this one together, and then I'll have you do the next one on your own. So recipe calls for 1.75 cups of oil. Okay, we don't have any measuring cups, but I've got a graduated cylinder at school. So, how could I convert that from the cups to the milliliters, which is the unit of measure on the graduated cylinder? So you see here, I can go from cups to gallons, and then I can go from gallons to liters. And then our next lesson is going to be about metric equivalencies. And maybe you know these already. I think you probably do from previous science and math classes, but if not, we are going to review those tomorrow. But we'll need to use that conversion from liters to milliliters. So again, we always start with the number that we're given and put a label on it. That's really important, okay, because it's factor label. So we need to start our conversions, and remember, we could go from cups to gallons. And we know there's 16 cups in a gallon. Again, I put the cups on the bottom, so that the unit would divide out. And then we also, on that previous slide, had the information that a gallon is the same as 3.78 liters. So again, I put the gallons on the bottom this time so that my gallon unit would divide out. Now, if this said, the volume in liters, we'd be done. But we'll do one more step to convert from liters to milliliters. I got to put the liters on the bottom. And tomorrow we will review our metric. A milliliter is 1/1000th of a liter. So you could use 1 times 10 to the negative third, or you could put it in standard form, 0.001. So you tomorrow you'll see you could use this too. That's the same thing as 0.001. You guys know that from when we did scientific notation. Liters will divide out. Our answer will be in milliliters. In this particular problem, when we're plugging it into the calculator, you take 1.75, you divide by 16 because it's on the bottom, multiply by 3.78 because it's on the top, and divide by 0.001 because it's on the bottom. And when you do that, you should get 413 milliliters. Okay. And in all the problems today, I'm going to be rounding off. I am not going to be worried too much about sig figs. That lesson is coming. But we're more worried today about just making sure we get the process. So I'd like you to try this problem. Maybe pause this presentation and set up this problem and calculate an answer. Okay, now hopefully you did that. And we'll go over quickly. You'll see in this one, there's 2 different ways that people could have gone with this. There are people who would say, oh, I know that a yard is 36 inches. That's fine. There's also going to be people who set this up and they know that a yard is 3 feet and they know that a foot is 12 inches. You see how these are going to yield exactly the same result, and either way is just fine. In both of them, we've obeyed the rules where the top and the bottom of the factor are equal. 1 yard is indeed equal to 3 feet, and 1 foot is indeed equal to 12 inches. And, up here on the top one, 1 yard is indeed equal to 36 inches. So this doesn't ask us how many inches long the football field is. It asks for centimeters. You go back a few slides. We did have that equality. that an inch is 2.54 centimeters. Okay. And so we know that an inch is 2.54 centimeters. So all of these, if you look at how we set them up, okay, we make sure that whatever unit is on top, like inches, it's on the bottom of the next factor so that it'll divide out. And we end up with centimeters. Here our yards divide out, our feet divide out, the inches divide out, and we end up with centimeters. And you can try plugging either one of these in, and you should get 9,144 centimeters. So that is the length of a football field in centimeters. Now, one of the things I do want to mention is that some of these conversions like this, I did not give you on the previous page, that other slide. That's because these, I expect, are common knowledge, kind of like the ones where we did the birthday and then, how many hours are in a day, how many minutes are in an hour. There are some common knowledge conversions that I think that you should know. But then some of the other ones that you were given on that previous slide, you don't have to memorize. If we have a quiz or a test, I will give those conversions to you for your use. Okay. So hopefully you're able to do where you have one unit and you convert it into a new unit. And then hopefully you also are recognizing that the beginning and ending quantity, these are exactly the same distance. It is just very simply a distance or length that is represented in a new unit. So you have a different number, but these are equal to one another. 100 yards and 9,144 centimeters are exactly the same length. Okay. So if you look at this one, take a second to read it. You may notice that in this one, there are actually two different units. There's miles and there's hours. Okay. When you have two different units, and you might have this with like intensity, like grams per milliliter, or in this case, a speed, it's very much recommended that the way you do this is not to go like miles per hour. Okay. I would not do that at all. What I would do instead is do this, where you're saying, okay, it's miles. That's how many miles you drive in 1 hour. Okay. So we have two different numbers here that we need to convert. We need to convert our miles into meters, and we need to convert our hours into seconds. And quite honestly, it doesn't matter which one you do first, as long as you keep top and bottom of the factor equal, and you set it up so that the units you want to get rid of divide out. So, for example, we want to put the miles in the bottom so that it'll divide out. If you go to that previous slide, I had given you the fact that a kilometer is 0.62 miles. So that will let the miles divide out. Now we will, again, we will have metric. We've got to convert this to meters. So we got to get rid of the kilometers and get the meters. We will have metric on our next lesson, but a kilometer is 10 to the third meters. So you could either put like 1 times 10 to the third, or the other thing that you could put in there, 1 times 10 to the third, that's the same as 1,000. So either way, standard or scientific notation is fine. But you see how we set it up so the kilometers divide out. And now the unit that we are left with is on top meters. So we're good. That's what we wanted, right? But right now, if I divided by 0.62 and multiplied by 1,000, I have meters per hour, and I want meters per second. So I have to convert my hours into seconds. Now this time, when I convert from hours to minutes and then minutes to seconds, I have to put the hours on the top, because here hours is on the bottom. It needs to be on the top over here so it'll cancel or divide out. So we know that an hour is 60 minutes, and we know that a minute is 60 seconds. Now my minutes have to go on top in that factor so that it divides out. And when I'm done, I have meters on top and seconds on the bottom. So my answer has units of meters per second. And to solve this, I will take 55, I will divide by 0.62, I will multiply by 1,000, I will divide by 60, and I would divide by 60 again. And I would get 24.6 meters per second. That is exactly the same speed as 55 miles per hour. It's just expressed in a different unit. Now, in the next problems, what we're going to talk about is what do you do if you have squared or like cubed units? Okay, how do you convert those? So a box of Reynolds wrap, I looked on the box of Reynolds wrap that I have at home, and it says that it is 75 square feet. Okay. But I have something that I need to coat with the foil, and I need to know how many square meters are available. So I need to do a conversion so that I can, compare this. So again, I'm going to just start with a number I'm given, but this is square feet, so this is feet squared. And what you want to do is just set up your factor like you would if you were going from feet to inches, and then we'll go from inches to centimeters and centimeters to meters. But when you set this up, like we know a foot is 12 inches, you have to square this factor. So now that means not only are you squaring the unit, but you're also squaring the number. So if we convert 75 feet squared into inches squared, I'm going to have to multiply by 12 twice. Or I'm going to have to take 12 squared is 144, and I'm going to have to take 75 times 144. Now, this wants the area in meters squared. So I got to keep going. I know that an inch is 2.54 centimeters. And again, I have to square this so that my inches squared divide out. If this asks for square centimeters, I'd be done, but it asks for square meters, so I need to go from centimeters to meters. When I learned metric, I found that a centimeter is 1/100th of a meter. So 1 times 10 to the negative 2 meters, or 0.01 meters. Again, I need to square this. And you can see why. My feet squared will cancel out. My inches squared will cancel out. My centimeters squared will cancel out. And I will be left with meters squared. Now to solve this, I either need to solve each one of these and get a number, or, just go through and set it up in your calculator. 75 times 12 twice, times 2.54 twice, or times 2.54 squared, and then times 0.01 twice, or times 0.01 squared. Make sure, try that in your calculator, because every once in a while people are going to use the squared. They need to use parentheses. Depends what kind of calculator you have. And I got 6.97 meters squared. Now, I wouldn't really have had to do this because my roll of aluminum foil had actually had that answer. And many products today are marked in both English and metric units because international companies, and we are a country that still uses these English units like feet squared, but many countries in the world use metric units like meters squared. So what if you have like a cubed unit? I have a rock and its volume is 95 centimeters cubed. Okay. If you have a case like that, you do it exactly like the last problem, only you cube each factor instead of squaring it. So for example, we're starting with our 95 centimeters cubed. And we want the volume in cubic feet. So we have to go from centimeters to inches, and then from inches to feet. We know that an inch is 2.54 centimeters. And we got to cube that factor. We know that a foot is 12 inches, and we got to cube that factor. So to solve this, we're going to have to take that 95 and divide by 2.54 3 times, or divide by 2.54 to the third. And then we're going to have to divide by 12 3 times, or we're going to have to divide by 12 to the third. When you do that, you get an answer 1.24 times 10 to the negative third. So you can do it this way. And that is feet cubed. Now, a foot is a much larger unit than a centimeter, so I do expect to get a small number when my unit of measure is very large. If your calculator gave this to you in standard form, that would certainly be acceptable too. Okay. Either one of these are exactly the same volume as 95 centimeters cubed. Now, the last problem that I want to show you, because you're going to have some that you're going to solve this year, and we're going to practice some in homework and in WebAssign, where maybe some of the factors have to be squared or cubed and some of them don't. Okay. Like you could have a density in grams per meter cubed. And you're supposed to find it in like kilograms per centimeter cubed. I mean, when you're converting the grams to kilograms, that's not a cubed unit. When you're converting the centimeter cube to meters cube, or I can't remember which way I said it, but that's a cubed unit. You'd have to cube that factor. Well, this is a problem that you're starting out though with a unit. It's just one unit, and it's not cubed, but you're ending with a cubic unit. Okay. And so at a certain point here, we are going to have to cube some factors. So let's take a look at this one. And if you've ever been to Disney's Typhoon Lagoon, it's really fun. Okay. Each single wave is that many gallons. Now I'm going to put that in scientific notation to start. That's 8 times 10 to the fourth, and that's gallons. Okay. And we eventually want that in cubic meters. Okay. So we're going to go from, we know a gallon is 3.78 liters. We know the conversion from liters to milliliters, or we will tomorrow. We know a milliliter is 1/1000th of a liter. Now here's one that you're going to learn tomorrow. A milliliter and a centimeter cubed are the same thing. They are equal to one another. And I'm kind of running out of room, but let me see if I can fit it in here. We know from our previous metric that a centimeter is 1/100th of a meter. Okay. Now this is sticking out to me like a sore thumb right there, that cube, because down here we just have centimeters. It's not centimeters cubed. So what you have to do to get that cubed, okay, is just cube that factor. And now the gallons divide out, the liters divide out, the milliliters divide out, and the cubic centimeters will divide out. And the answer will be in meters cubed. See, some of the factors, the first three, they don't need to be cubed. Right here, this is where we switched from a non-cubed unit to a cubed unit. And we'll learn a little bit more about that tomorrow. And after that, now my factor has to be cubed. So when I am solving this, I'd take 8 times 10 to the fourth. I would multiply by 3.78. I would divide by 0.001. Multiply by 1, divide by 1. Doesn't do anything. And then multiply by 0.01 3 times, or 0.01 to the third. And I just rounded it off, and you get 302 meters cubed. Now, you can see that sometimes you've got to cube factors. Sometimes you need to square them. Sometimes in your problem, you're changing two different units. Don't try and change them both at once. Just start with the one and then try the other one. And it really doesn't matter which order. I could have changed the hours to seconds first and then worked on changing the miles to meters and gotten exactly the same answer. And then sometimes there's more than one way to do it, depending on, what you're familiar with. Like some people know how many cups are in a gallon. But there's maybe other people who say, all right, I know how many cups are in a pint, how many pints are in a quart, how many quarts are in a gallon, and they would use several factors. Me personally, because it's the English system, I probably have to look all of those up, which is why we're soon going to be talking about metric, because once you learn those metric prefixes, you don't have to look up all those different units in the English system. But basically, you should be able to apply this factor label method to solving a variety of problems. We want to be able to change 1 or 2 units, okay? And we want to be able to change things that are squared or cubed. So good luck with the problem solving, okay? And let me know if you have any questions.